Meridians, north points, lines, the compass, a sense of direction in surveying. Good day everyone, I am Michael Eclipse.
I am Julius Victor Iduran.
I am Marinel B. Espinosa.
I am Erica Igana.
And we're going to discuss measurement of angles and directions. In this chapter, we are going to talk about the importance and relation of meridians, north points, direction of lines, and the compass in surveying. We will introduce concepts and provide specific examples that will give us adequate information and help us learn more about proper surveying. Now, let's start with meridians. Meridians are fixed imaginary reference lines of longitude along the Earth's surface, meaning vertical imaginary lines here that extend from the North to South Pole. Determining the meridian is very crucial in surveying since it is a line by which we measure the angle of any line. So let me introduce you the 4 types of meridians according to Laput's book on elementary surveying. So the first one is the true meridian, also known as astronomic or geographic meridian. It is the direction of the line passing through the geographic north and south poles of the Earth and the observer's position. Looking at the Earth's surface, these vertical lines from the geographic north to geographic south are the true meridians. True meridians are not parallel to each other. Why? Kaya syempre, since na-converge or connected at era end north and south poles, makikita naton nga it follows the shape of the Earth. Diri man hiya flat surface, oblique sphere man it Earth, that is why it's not parallel with other true meridians. And since the direction of the true meridian remains permanent and unchanged regardless of time, this makes it a good reference line. That's the reason why it is generally adopted in surveying practices. There are studies proving that the Earth has magnetic forces, and it is identified that there has to be a meridian that follows and lies parallel to the magnetic fields. This meridian is called the magnetic meridian. A magnetic meridian's direction can be identified using a magnetized needle of a compass at the observer's position. Since na-rotated Earth on its axis, diri aligned it true meridian yan magnetic meridian. Ang location and magnetic poles kay nag-iiba, nag-change siya from time to time. The direction of the magnetic meridian is not fixed and permanent. Because of this, it is used as a line of reference only on rough surveying that uses magnetic compass in determining directions. Now let's move on to the third meridian, which is the grid meridian. It is a fixed line of reference that is parallel to the central meridian. It is used when computing points in planar rectangular coordinate systems of limited extent. Actually, ang central meridian kay amo it true meridian where it iba nga vertical lines kay ginpaparallel hiya to form a parallel vertical imaginary lines. So the fourth meridian is the assumed meridian, also known as arbitrary meridian. It is a chosen fixed line of reference taken for convenience. Inina type of meridian kay ang direction tikang hausa na service station pakadto hit another point kung nga in ka magsa-survey. Just like it illustration na ada. Ginagamit hiya only on plane surveying ngan limited surface la kay makuri mabilngan otro if ever mawara or waray ka record an original mo na reference point. Okay? So now, let's move on to the expedient methods of establishing meridians. Like what I have said earlier, determining the meridian is very important in surveying kay using the meridian, we can identify directions and measure angle of any line. So, I'm going to present methods or ways on identifying directions na very useful in actual surveying and even in designing an architectural building since we plan on spaces in accordance with the north-south direction and the sun's path. So, here are some methods. The first one is establishing magnetic meridian by compass. The magnetic meridian can be identified using a compass over any convenient point. In determining the north using the compass, it must be rotated about its vertical axis and then positioned until the compass needle reads 0. So it arrow kaya ada habot nga hit north sign. Kung aligned na hiya ha 0, then that is the true north. Then after that, in order to identify the magnetic north or the magnetic meridian, we must calculate the magnetic declination that will be discussed further in the next lesson. So to give you an insight about it, magnetic declination differs from one place to another. Bali, nag-iiba-iba at magnetic declination depende kung hain ka na place or kung hain na point it imogin sa survey. So in our example, as what is shown in the picture, we have a 13 degrees west magnetic declination. Since you have the magnetic declination, you rotate your compass and align the needle on the 13 degrees west magnetic declination. So kung naka-align na hiya, we can find the magnetic north as well as its meridian. Don't worry kay we will discuss further on how to get the magnetic declination of a bearing para mas maka-learn ka mo on how to use the compass. So for now, let's move on to the second method, which is determining true north by aid of sun and a plumb line. In this method, we need sticks, strings, and the sunlight, of course, para ma-identify a true north through shadows. First is maghimo ka hin support for the wooden pole using two supporting sticks na connected each other. Then, after that, place a wooden pole kung nga in iga-attach ang string for the plumb line. Don't forget na but ngan hin weight and endhan wooden pole as you can see in the left side of the picture. So, once na mabitay na ang sharpened stick using the string, mark the tip of the shadow an hour before noon. Pwede mo but ngan hin stone to identify ito na point na 1 hour before noon. So, ma-measure ka na liwat in another point an hour after noon na. Yan na, di ba may daka na 2 points. So we can identify the direction of true north by finding first ang midpoint hito na duduwa na point na aton gin measure. So kung hain it but nga hito na 2 points, the midpoint, kay amo liwat it direction and true north. Now let's move on to the third method, which is determining true north by rising and setting of the sun. The earth rotates counterclockwise, so the sun always rises in the east and sets in the west. In the morning, find the general location of the sun. Use your hand and point towards the sun, but make sure na don't look directly at it kaya syempre madadamage it your eyes. So, yan na. Kung ngayon ka na nag-point nga nag-set ang sun is the east direction. Now, point your another hand in an opposite direction ngan inina direction kay kung ngayon nag-set ang sun, which is the west direction. Remember na when it is noon or when the sun is at its highest peak, kay ngadto mabibilngan it north pole regardless kung ngayon ka na location. So in short, at noontime, kung hain it direction it sun, kay amo liwat it direction hit true north. So the fourth method is the determining true north by Polaris. In this method, the Big Dipper constellation is very useful in determining the direction of true north. Why? Because inina constellation kay na-point towards the Polaris or also known as the North Star. There are 7 na stars inina Big Dipper and the 2 stars named Merak and Dobby na na-formhan side hand Dipper kung ngayon na-point ha direction hand Polaris. Ngan it Polaris liwat kay almost directly above the Earth's North Pole. So basically, if we are facing towards the Polaris, we are already facing the direction of true north. And now, let's determine the true south by the Southern Cross. The Southern Cross is a constellation of the southern hemisphere that serves as a reference in identifying the direction of the south pole of the Earth's surface. Actually, its Southern Cross kay may ada 4 na stars nga na-form bagahin cross. So, to identify the true south, ang distance between the 2 stars nga masilaba kay ginmultiply la by 4.5. So, as you can see in the picture, may ada imaginary lines nga na-extend na 4.5 times the distance of the 2 stars. Therefore, the true south can be identified or determined since above man lahiya ito na calculated point and end point and 4.5 times the distance between ito na duduwa na star. And the last method is the most interesting one for me since we determine the direction of true north or true south using an ordinary wristwatch. However, this method is only applicable for those places na aada ha temperate zones. To identify the direction of true north and south in the north temperate zone, first is hold the watch horizontally and point the R hand directly from the sun's direction. So an R hand kay ngadtuhan direction ng sun. Now, form an angle between the R hand ngan ang 12 o'clock mark. So, may ada ka na angle diba? After hito, ma-identify mo na it true south by determining the midway between that R hand ngan ang 12 o'clock na mark. So, establish a line na katunga hito na angle ngan amo ito it approximate direction of the true south. Ngan of course, if we already know ang direction ng true south, ha opposite direction liwat mabibilngan ang true north. Now, let's move on to the units of angular measurement. The magnitude of an angle can be expressed in different units. Actually, tikang hiyahit division or pagtutungay circle. Nag-iiba-iba lahiya ha units, but they have equivalencies. So, here are the units used in angular measurement. First is the degree or also known as sexagesimal system, wherein the circle is divided into 360 parts or 360 degrees. A degree is further subdivided into 60 minutes and a minute is subdivided into 60 seconds. This unit is widely used in surveying practice. The next one is the grad or also known as the centesimal system, where its circle is gintungahiya into 400 parts or 400 grads. Note na 200 grads is equal to 180 degrees. A grad is subdivided into 100 centesimal minutes and the centesimal minute is subdivided into 100 centesimal seconds. The third one is the mil, where its circle is gintunga into 6,400 parts or 6,400 mils. So, meaning na 1,600 mils is equal to 90 degrees. So, and the last unit of angular measurement is the radian, or referred to as the natural unit of angle because there is no arbitrary number in its definition. So, radian kay another unit of measure of angles that is frequently used in calculations. So, 1 radian is an angle subtended at the center of the circle by an arc length that is equal to the radius of the circle. So, 1 radian is equal to 180 over pi or approximately 57.2958 degrees, and 1 degree is equal to pi over 180 or approximately 0.0174533 radians. Designation of north points. There's always a starting point or reference in defining directions. So I'm going to present commonly used reference points in determining directions. First, we have the true north. It is the north point of the true meridian. It is the actual geographic north pole of the Earth's surface that is always along a vertical line. So the next one is the magnetic north. It is the established north point of magnetic meridian when using a magnetized compass needle. Its direction is changing and not aligned in the true north since na i-indicate it iya direction depending on magnetic line of force passing through the Earth's surface. Next one is the grid north. It is the north point that can be established or determined by lines on a map which are parallel to a selected central north. So iniya kay a north point han grid meridian where applicable la for flat or plane surfaces. And the last one is the assumed north. Assumed north is used to portray the location of any arbitrary chosen north point, meaning can iya reference point from random lana location in surveying, and it is usually used in flat surfaces lagi hapon. Prepare your calculators and let's learn on how to convert units of angular measurements. The conversion of an angle to decimal degrees. So we have this problem. Convert the angle 238 degrees, 25 minutes, and 50 seconds into its equivalent in decimal degrees. To find the decimal equivalent of this angle, ig-a-add taan degrees and minute over 60 plus second over 3,600 since there are 60 minutes or 3,600 seconds how 1 hour. So let's substitute. So 238 degrees plus 25 minutes divided by 60 plus 50 seconds divided by 3,600. 238 degrees plus 0.4167 degrees plus 0.0139 degrees. So after adding this, we will get the value of 238.4306 degrees as our decimal equivalent of an angle. Next is the conversion of an angle to degrees, minutes, and seconds. Convert the angle 325.7541667 degrees to degrees, minutes, and seconds. Since na itiya unit kay degrees naman, we will just get the integer portion of that decimal degrees. So, i-exclude or dili na go-upod ang mga numbers after hit decimal point. So, we will have the value of 325 degrees. So next, i-convert natin ito na angle into minutes. By using the formula degrees minus the integer portion of the decimal degrees multiplied by 60 minutes divided by degrees. So substitute degrees, kay anong degrees? 325.7541667 degrees minus adina d is 325 degrees multiplied by 60 minutes divided by degrees. So, i-calculate natin adihiya ang 325.7541667 degrees minus ang d na 325 degrees kay ang value na 0.754167 degrees. Yan, i-multiply na natin hiya by 60 minutes over degrees. Yan, cancel ang degrees, so ang minutes na laan masasalin. So, by calculating it, we will get the value of 45.2500 minutes. So, we will get the integer portion of the angle in minutes. So, igtatanggalit numbers after the decimal point. So, we will get the value of 45 minutes. So, next, i-convert natin ang angle into seconds. So, we will use the formula seconds is equal to minutes minus the integer portion of the minutes multiplied by 60 seconds over minutes. So, substitute again, 45.25002 minutes minus 45 minutes. Ngayon, multiply by 60 seconds over or divide ha minute. Cancel na liwat ang minute na unit. So, ang seconds nala ang masasalin. So, since na dapat aton kukuhaon kay ang integer portion la ay han seconds, so we i-exclude na liwat naton ang numbers after hit decimal. So it aton la seconds is 15 seconds. So therefore, it angle na 325.7541667 degrees is equal to the summation and kanan degree and minute ngahin and second nga equally what ha 325 degrees 45 minutes and 15 seconds. So next is the conversion from degrees to grads, mils, and radians. Convert 270 degrees into its equivalent value in grads, mils, and radians. Inihiya kay may dala actually formula na ginagamit. So angle in grads is equal to kung ano't aton ko convert multiplied by 400 grads divided by 360 degrees. So by calculating it, makukuha naton it 300 nga grads. So next is angle in mils. Amo laliwat. It nga din na part is aton i-convert is i-multiply ta by 6,400 mils divided by 360 degrees. So we will get the value of 4,800 mils. Masayon la, diba? So next liwat kay kukuha naton ang angle in radians. So 270 degrees multiplied by 2 rad divided by 360 degrees. So after calculating it, we will get the value of 4.7124 radians. We will convert the angle from grads to degrees, mils, and radians. The value of an observed interior angle in a closed traverse is 350 grads. Convert the angle into its equivalent value in degrees, mils, and radians. So at atong ibibilngin kay i-convert naton inihiya nga 350 grads. So first is may dala actual nga formula. Ang aton i-convert is i-multiply naton by 360 degrees over 400 grads. So i-multiply na nga niya by 350 grads, we will get the value of 315 degrees. So kay ano degrees an unit, kay syempre i-cancel naton ang units han kanan grad and 350 grads ngayon for 400 grads. So ang degrees na laan masasalin kanan didi. Okay? So next is i-convert naton ang grads to mils. And 350 grads is multiplied by 360 degrees over 400 grads. So nga di, na-cancel na ang grads. So degrees na lahiya. Pero takait aton yung bibiling kay mils man. So we will multiply it again nga to hit another units na which is mabibilingan an mils. Igmo-multiply na liwatiya by 6,400 mils over 360 degrees. So maka-cancel na ang 360 degrees nga diliwat ang 360 degrees. So ang unit na lang ang mabibilin kay mils. So pag mo i-multiply na hiya, we will get the value of 5,600 mils. Okay? So next, we will convert the grads into radians. So now, we will multiply 350 grads by 360 degrees over 400 grads. So matatanggal na ang grads. So degrees na laliwat ang masasalin. However, radians man at aton yung bibilin. So, i-multiply again hiya naton by 2 pi rad over 360 degrees para matanggal it unit na degree ngayon radian na lait masasalin. So after calculating it, i-multiply lahiya, we will get the value of 5.4978 radians. Conversion from mils to grads, degrees, and radians. Convert 1,600 mils into its equivalent value in grads, degrees, and radians. So first, is i-convert naton ang mils into grads. So, i-multiply lang naton ang aton mils na aton i-convert, which is 1,600 mils by 360 degrees divided by 6,400 mils and then multiplied again by 400 grads over 360 degrees para matanggal ang unit na meals and then degrees para grads la it masasalin. So after mo i-multiply iton hira na tanan, we will get the value of 100 grads. Next is we convert the angle in degrees. So 1,600 meals is multiplied by 360 degrees divided by 6,400 meals, and we will get the value of 90 degrees. Lastly, we convert the meals into radians. So 1,600 meals is multiplied by 360 degrees over 6,400 meals. So nga di, may ika-cancel mo na ang meals. So may dapasalin di ba na degree na unit. So we will multiply it again by 2 pi rad over 360 degrees para mabilin na natin mabilin nala ang rad na unit ngan makancel adihiya na degree. I-calculate and i-multiply mo na hira nga tanan, we will get the value of 1.5708 radians. And lastly is the conversion from radians to degrees, grads, and meals. If the value of an angle of elevation is computed to be pi over 4 radians, determine the equivalent value in degrees, grads, and meals. So inihiya na pi over 4 radians kay go-convert naton into degrees, grads, and meals. So first, i-convert naton hiya degrees by multiplying pi over 4 ngahin and 360 degrees over 2 pi. So i-calculate naton hiya, we will get 45 degrees. So degrees na nga unit since an pi nga di ngan an pi han 360 degrees over 2 pi kay makakancel na. So an degrees nala an masasalin. Okay? So next, i-convert naton in an radians into grads. Same process lagi hapon hiya, but mas halaban na hiya since di ba kanina may da kita degrees na hiya, pero takay tatging bibiling grads. So we will multiply it again by 400 grads divided by 360 degrees para makancel and 360 degrees ngan grads na light masalin. So after multiplying it, we will get the value of 50 grads. And lastly, we will convert the pi over 4 radians into meals. So multiply pi over 4, 360 degrees over 2 pi, and multiply it again by 6,400 meals over 360 degrees. So after multiplying it, we will get the value of 800 meals. So kay ano man meals na yang nga di. So syempre kay nga di na-cancel na ang pi, na-cancel na ang degrees. So ang masasalin na lang na unit kay is meals.